The molten core 3,000 miles underneath our feet is hotter than the sun's surface. Incredible amounts of energy are waiting for us. Only 0.1% of this energy would be enough to power the entire planet for 20 million years. But unfortunately, geothermal only makes 0.3% of the world's energy supply. Most of that heat source is only available at depths of several miles, and access to it is extremely difficult. But an MIT startup wants to change that now to make this infinite energy source available everywhere on Earth for a zero-net emission future. With a new breakthrough drilling technique, they want to drill 12.5 miles, 20 kilometers deep into the Earth, deeper than any borehole done before. How do they want to make this possible? How realistic is this concept to achieve worldwide? And what can we really expect from this concept? Because in addition to the great potential of geothermal energy on a global scale, there are also big dangers coming with it. Join us as we explore the MIT technology that will change everything for geothermal on a global scale. Every 300 feet beneath our feet, it gets 3 degrees Celsius warmer, eventually reaching temperatures of about 5 to 7,000 degrees Celsius. The heat that comes from the inner Earth is approximately composed like this. 30% of it comes from the Earth's core itself, which stems from the formation of the planet. Another 70% comes from the decay of radioactive elements in the Earth's crust and mantle. By human standards, it's an infinite source of energy, as Earth's core will likely continue to glow for another million years. If so, why don't we use this energy source already? The answer is conventional geothermal energy is only accessible in places with high volcanic activity, such as Iceland. Most other countries have to drill several miles deep to reach profitable temperatures. Reaching those depths is not possible because of the high drilling costs and time. Therefore, currently the world's deepest borehole is in the Russian peninsula Kola, with a depth of 7.5 miles. It was made in the Soviet times for research purposes and was also called the Hole to Hell. No one has ever drilled deeper into the Earth before, but an MIT startup called Quaise Energy wants to drill even further, up to 12.5 miles deep into the Earth, and make ultra-deep geothermal systems available everywhere. The reason they want to drill that deep is because water can achieve its fourth supercritical form with the available heat there. This, in turn, increases the efficiency of geothermal power plants enormously by 10 to 20 times. Conventional geothermal power plants have an efficiency of only 5 to 15%, which is pretty low. Temperatures in excess of 200 degrees Celsius can already be reached at depths of 6.2 miles. At 12.5 miles, the available heat increases to as much as 480 degrees Celsius. The energy density is sufficient to provide clean, carbon-neutral heat for most fossil fuel-fired power plants. The entire power plant infrastructure could therefore be used as an energy transition with geothermal. This would save time, resources, and above all, costs. That's one reason why this concept is highly promising. For comparison, just one of those supercritical geothermal boreholes could provide 35 megawatts of energy, the same energy output as 35 wind turbines. The residual heat of the energy generation process could be used to supply industry or even heat greenhouses, fish farms, or aquaculture and buildings. A major advantage of geothermal energy is that it is available 24 hours a day, 7 days a week. There are no weather-related or seasonal fluctuations like in solar and wind power. Therefore, geothermal energy is theoretically absolutely baseload capable. But how is it possible to drill that deep and stay profitable at the same time? Drilling costs typically increase exponentially with increasing depth. The effort increases with every drilled mile and thus becomes more expensive. This is not the case with the new drilling technology. The costs remain linear, so the concept is practical. But for this drill, the world's most powerful gyrotron is required. A gyrotron is a device that emits high energetic millimeter waves. It is typically used in nuclear fusion tokamak reactors to heat the plasma to the tremendous heats required for the fusion process. Therefore, the gyrotron can continuously generate an energy beam of 1 megawatt. So when this enormous beam of energy is focused on the Earth, it would disintegrate the rocks without even directly touching them. In other words, the stone is pulverized by a laser beam. With a vacuum tube, similar to fiberglass tubes, it is possible to conduct these high-frequency millimeter waves over long distances with almost no loss. Even after 6.2 miles depth, 90% of the energy is still available to drill even further. So it is also a really efficient method. Quaise Energy claims that with their new drilling method, they would be able to drill these ultra-deep boreholes in just 100 days. For comparison, the deepest drill in Russia has taken almost 2 decades. To achieve their goal in that fast fashion, Quaise Energy plans to use a hybrid drilling method with conventional mechanical drills. They plan to drill the first rock layers to a depth of about 5 kilometers. The gyrotron then takes its place to drill even further through hotter rocks with hotter temperatures. The advantages of this method are clear. First, there are no mechanical drills that wear out with time and have to be changed regularly. And there is no rock too hard nor a temperature too high for the gyrotron. So theoretically, also, no limitations for the drilling depth. It sounds great at first glance, but can we carelessly bore mile-deep holes into the Earth without any consequences? What are the dangers of geothermal power plants on a global scale? In fact, these could be pretty critical. The risk assessment of some experts for geothermal energy as an energy production method is extremely optimistic and describes the risk as low and only given locally. However, the problem with this classification is that no drilling depths of 12.5 miles have been considered, and plans on the global scale, as Quaise envisions them, have not yet been included in the evaluation. In fact, geothermal energy could drastically increase the risk of earthquakes. Geothermal power plants in Germany, but also in New Zealand, have already contributed to measurable movements of the Earth's surface. However, it is difficult to say how high the risk really is. The interior of the Earth is a so-called chaotic system, which is very difficult to describe mathematically. This is also the reason why we can hardly predict volcanic eruptions and earthquakes. So we don't know how dangerous geothermal energy is until we've tried it out on a large scale. What other dangers do you think deep geothermal systems would also have? Please tell us your thoughts in the comments below. It is also unclear whether the overall concept of the global geothermal energy supply, as Quaise envisions, really works out. The theory is great, but the company has to survive its first drill test of 12.5 miles. If they succeed, they plan to bring their first commercialized geothermal power plants online by 2028. In any case, investors believed in the geothermal and invested a total of $52 million US. Only time will tell whether the money is well invested or not. Personally, I think the concept is incredibly exciting, but other energy concepts are very promising as well. The first molten salt thorium test reactor recently went online in China and will generate enough electricity to supply hundreds of thousands of people after its testing phase. This type of nuclear power should deliver more energy and is meltdown safe at the same time. Click on the displayed video to learn more about the thorium breakthrough technology. And don't forget to subscribe to my channel for free so you don't miss out on any new videos.